I'm Shelby Doolittle, engineering lead for the Fractal Protocol, and I'm here today to talk about some of the current and planned technology we have for the Fractal Protocol, how it works, and why it will be valuable. The core of the technology is the data host. The data host is the term we use for the portion of the system that stores users' behavioral and factual data. Behavioral data being what page views you visited, what videos you might have viewed, what purchases you've made, things like that. And factual data being things that are unlikely to change about yourself. So your place of birth, your date of birth, your gender, um, things like that. This is different from application data, which, for example, would be a video you created to share with other people or a post you made on a social media site, where application data is meant to be shared pretty much uniformly, potentially across the entire internet. Behavioral and factual data is really only generally intended to be used to enhance an existing application with potentially better recommendations or potentially targeted advertising, things like that. So while you can store application data in a data host, it doesn't really make sense. It doesn't really fit the use case. The data host allows for sharing data in multiple ways. The goal of the data host the goal of the Fractal Protocol in general is to make your behavioral and factual data as useful as possible while keeping the user's privacy at the forefront. So if a user doesn't want to share their data with specific groups or in specific ways, then they don't have to. And we are building tech to try to allow your data to be as useful as possible for the applications you use and potentially for advertising while maintaining your privacy preferences. So some of the ways that we allow for accessing the data is homomorphic encryption, compute to data. You can access the data directly if the user is okay with that, or for proving certain facts about your data set to fulfill transaction requirements, for example. So these all have different trade-offs in terms of what you can do with the data and in how much actual access you get to the data. And these all have different trade-offs, and we will expose these cleanly to the user so that they can understand the implications of what's actually going to happen here. And there are many, many more ways that we have already thought of and might potentially think of to share this data in the future. Data host also aggregates data across your devices. So that means that you browse on your laptop, on your mobile phone, on your desktop. You might use a connected device to your TV to watch content. And we want to connect all of these so that applications can look at your entire behavior across all of these different devices that you end up using, and that you can get rewarded for the content from all of these devices together. So while these might be stored on separate devices, we can logically merge them into one consistent stream of this data. So let's talk about the architecture. So logically, the data flow starts at the bottom here with this application and this user. So that would be you do a search on a search engine, and the application, which in this case would be the search engine, would tell you, hey, here's a piece of data. Here's a piece of data you might want to store in your data host. If that is within your privacy preferences, like you choose to store your search engine searches in your data host, then probably the Chrome extension that's acting as a data host for you would pass the check and would end up storing that data. Sometime later, we move to the top of this diagram where another application comes along and would like to view some portion of your search history or run some algorithm on your search history. And assuming that's okay with your privacy preferences for what you've chosen, it will be able to see that specific search you just did towards the bottom of this diagram. And then there's a potential for if you have a transaction tied to that data access, like if an advertiser wants to pay you to click an ad, assuming that you have searched for dog food in the past 3 weeks and they're advertising dog food to you, they might say, prove that you have this type of data and we will transfer these funds to you. That will be then that proof potentially, and the transaction will have to be submitted to a blockchain. We are trying to minimize the amount of data that actually has to arrive on the blockchain. And so far, our plans are to have very little, maybe a few hashed pieces of data, or maybe just just a few little bits and pieces of actual data structures arriving on the blockchain. And that will all be, of course, be configurable in the data host privacy preferences. So let's talk about some of the specific tech we've made for this system. So since the core of the system is sharing and accessing data, we need some underlying way to transmit and interact with that data. And while there are a lot of well-trodden approaches for this data serialization, there isn't really one that quite fits our use case and doesn't have a lot of drawbacks for us. So we are custom designing a codec for storing and transmitting and interacting with this data that fits all of our use cases. So it's very much like protocol buffers or Apache Thrift, if you're familiar with those, but it is designed specifically for this use case. And we will have more information about this as we develop it more, as we document it more. We're also going to be using a Substrate blockchain that is an excellent system for just building blockchains easily. We only have to specify the portions that make our blockchain unique and not all the logic about transmitting blocks and gossiping transactions and things like that. So very useful there. And that will mostly be used for whenever there's an exchange of tokens that needs to occur as part of some application interaction, or potentially as the proof of data existence, where you can upload the root of a Merkle tree representing your data to later prove that you had some piece of data at or before some point in history. So we're going to have many libraries that will help you interact with the protocol in many different ways. There are a lot of different roles and a lot of different ways of interacting with the protocol, and we'll have libraries to support each of those. The first one that we're developing right now is the ability to run your own data host. So if you want to differentiate a data host and you think that you can, support some new way of accessing data or really fine-grained privacy controls, things like that, we want to encourage the community to create and operate these data hosts. So we'll have a library that will run whatever you don't care about for your data host. If you want to differentiate only on the privacy controls, then you don't have to worry about how to access the data. We'll already have a library that supports that for you. If you want to only differentiate on how the data is accessed in some new clever way, then you don't have to worry about the privacy controls. Our library will handle that for you. So you can customize the parts that you want, and you get the default behavior for the parts that you don't care about. We'll also have a library for data collection. So this will mostly be, for example, Chrome extensions that want to capture the user's browsing data and receive some portion of the user's rewards, something like that. Otherwise, and in some way monetize the data collection. Sorry, lost my train of thought. In some way monetize their extension by capturing data and providing it to the protocol on behalf of the user. This still won't allow you to violate the privacy guarantees that certain types of access have, but you can choose to monetize your application, and we'll have a library that makes it very easy to hook in and be one of these data collectors. We'll also have a library for providing data to a data host. So if you are, for example, a video streaming platform and you want to publish events to a user's data host when they pause or play a video, for example, and provide this really deep contextual data about how they're interacting with your system, then we'll have a library that you can easily hook in and easily just publish these events. And if the user has an operating data host and it passes their checks, then it gets stored. And if they don't, your application doesn't explode. So all of our libraries target a very simple interface for the developer, because we want as many developers building on our tech as possible, obviously. And we'll also have a library for data use. So if you're an application that wants to access all of your users' video plays and pauses, for example, or all of your users' search history, or the combination of the two, because you can develop something interesting that combines those two pieces of data, maybe, we'll have a nice library that lets you access that data. And we'll have smart fallbacks for if the user doesn't have a data host. So for some of the advanced tech that we might be using, we have an idea of a temporary state sidechain that would kind of allow public publishing of what are normally completely off-chain things in other blockchains, like state channels or temporary partial transactions, for example. We have some use cases that might require something like this. We'll probably not be getting to this for a while, and when we do, we'll start publishing some of our ideas to the open community and get some feedback from the rest of the community. So there are still quite a few open challenges in this project, and I just want to address some of them here so that you know that we're thinking about them. The core problem for this protocol is, how do we provide useful but privacy-preserving data access? Users don't want to just expose all of their data for very many good reasons, but it is good if you can actually get high quality content recommendations or high quality product recommendations from advertising for your behavioral data. When you have actual good targeted advertising, people like that. When you have good recommendations, people like that. But that shouldn't come at the cost of privacy. So general ways of doing this is hard, and there's probably going to be a few dozen different ways that you can access this data, all with different guarantees, and we need to present that well to the user. One of these is homomorphic encryption, for example, which allows you to only compute things like averages, but you don't get access to the underlying data basically at all. You have verifiable compute to data, where it's trivial to send an algorithm to another device, but it is not trivial to verify that that device actually did the algorithm correctly. So if you very much care about the Boolean result of your algorithm, you want to know that the person actually ran this against their data verifiably, but without having actual access to their data. And additionally, there's anonymous selective disclosure, which is our term for maybe you perhaps want to show that you visited petco.com, but not which specific product, not which specific URL, or not when you visited, but just the domain that you visited, and prove that that's in your data set and it happened at a specific point in time, but without proving anything else about that specific event. And that's actually pretty close to being solved. We have a pretty good idea of how to do that. There's also a big problem with scalability, and that is a problem for most blockchains, but especially for ours. There's a potential for one transaction every time an ad is viewed on the entire web with a naive implementation, and that is clearly not going to scale with existing blockchain tech. There are a few options for that. We can use some of the approaches that people have been talking about in the broader community for scaling blockchains. We might also be using this temporary state sidechain that I mentioned earlier to ease some of the burden on the main chain for this. We'll see. This is definitely a hard problem, and definitely one we're thinking about. So that's most of the tech that we have planned. We are starting a Fractal Builders program because we want developers to build applications that can use this captured data in really interesting and novel ways. We think that this is a new type of thing, where before, if you wanted to interact with all this data, you had to integrate with a bunch of different systems and get the user's permission explicitly to interact with all of these systems. And we don't really know what people might be able to build by having all this data easily accessible. We hope there's some really interesting things. Advertising is an obvious case, but not a particularly exciting one for kind of the artistic side of the creative process. So please, if you have any interesting ideas for stuff we might be able to build, even if you're not capable of building it, please submit your application to the link that I'll provide later, and please start the conversation with us. If you're accepted in this builders program, you'll get early access to these libraries. We might have, we might not generally support them early, but we'll, commit to specific features based on what your application needs. You might influence our development priorities, where if you specifically need homomorphic encryption or verifiable compute to data, we might raise the priority of us working on that to help you build this application. You might influence what data we focus on collecting. If you really need, search engine searches, then we can capture that before we might capture video views, for example. So here's the link for applying to that. Please do if you're interested, or even if you just have an interesting idea. We are actively looking for good ideas. Well, that's all for the tech. For the Fractal Protocol, we have a lot more planned. We have a lot that will be coming out soon, but this is all that we're able to share at this moment, or think is useful to share at this moment. If you have any questions, please leave them in the comments below. I'll be actively reading them, and thank you.